All right, this is section 7.2, which is finding cube roots. You found square roots before this, and now we're heading on to cube roots. So a cube root of a number is a number that when multiplied by itself and then multiplied by itself again equals the given number. So a perfect cube, just like we have perfect squares, we also have perfect cubes. A perfect cube is a number that can be written as the cube of an integer, and we will most likely have you memorize the cube roots up to 10. So 1 cubed is obviously 1. 2 cubed, which is 2 times 2 times 2. I won't do that all the time, but that's what that is 8. 3 cubed is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 243. 8 cubed is 512. 9 cubed is 729, and 10 cubed is 1,000. So those are the list of cube roots that we will probably have you memorize. So the symbol for a cube root is the square root symbol, but then you have to add a little 3 up there. So that stands for the cube root of 3. So let's find each cube root. So the cube root of 8. The cube root of 8 is 2. The cube root of negative 27, you have to think of what 3 numbers can I multiply by to get to negative 27. And it is negative 3 times negative 3 times negative 3, because that gives you positive 9 times 3 gives you negative 27. So the cube root of negative 27 is negative 3. And, oh, too far. The cube root of 1 over 64, the easiest way to do this is to split your fraction into a numerator into a denominator. So I have the cube root of 1 over the cube root of 64, and the cube root of 1 is 1. The cube root of 64, if we look over at our chart, is 4. So the cube root of 1 over 64 is 1/4. Note, so cubing a number and finding a cube root are inverse operations. Just like we've done addition and subtraction as inverse operations, we've done multiplication and division as inverse operations. So cubing a number, which is x cubed, and taking the cube root of a number are inverse operations as well. So we can use these when we're evaluating expressions and also when we're solving equations involving cube roots. Speaking of which, that's where we are moving on. We need to evaluate expressions involving cube roots. The most important thing to remember, you have to remember back to 6th and 7th grade, is you must use your order of operations. Okay, so we do our parentheses first, then our exponents, then we multiply and divide in the order that it appears, and then we add or subtract in the order that it appears. So looking at part A, we are going to first look at this exponent, which is, it's not really an exponent, it's the cube root, but it falls under the exponent category. Cube root of negative 216, if you look back up at your chart, the cube root of 216 is 6, and the cube root of negative 216 is negative 6. So this turns into 2 times negative 6 minus 3. All I did, oh boy, oops, sorry. All I did was find the cube root of negative 216 and call that negative 6. So now we're left with 2 times negative 6 minus 3. You do your multiplication next, so 2 times negative 6 is negative 12. And minus 3, negative 12 minus 3 is negative 15. Order of operations are key with these problems. Okay, part B, the cube root of 125 cubed plus 21. So we're first going to do the cube root of 125, and the cube root of 125 is 5. And then I still have it cubed there, plus 120, or excuse me, plus 21, not 121. I erase her out. Okay, so 5 cubed, 5 times 5 times 5 is 125. Plus 21 is 146. Now I want us to look closer at this part right here. Do you see how we take a number, we took the cube root of it, and then we cubed it, we were left with what's under the radical sign. Okay, so the cube root of something cubed again will always give you what's under the parenthesis. So for example, if we have the cube root of, let's say 64, and we cube that whole thing, the cube root of 64 cubed is 64. And the cube root of 1,000 cubed, you're left with what's underneath, which is 1,000. That's just a cool little trick that will be helpful when solving expressions. All right, you have 6 on your own problems. The first 3 are just using your cube root chart. Don't forget to split this one into a numerator and a denominator to help you on number 3. And on number 4, make sure you do first. And then use your order of operations. That should help you on those on your own. Example 3, we're going to evaluate x plus 4 plus the cube root of x over 3 when x is 192. So all we are going to do is plug 192 in where it says x. I'm going to start by rewriting the problem. So x over 4 turns into 192 over 4 plus the cube root of 192, which is x, over 3. So I have 192 over 4, which simplifies, I'm going to work this way, which simplifies to 48. And then I have the cube root of 192 over 3. Now, I told you before, sometimes it's easier to split this. But notice neither of these are perfect cubes. Okay, so sometimes it's easier just to divide those two numbers and to see if you get a perfect cube. So 192 divided by 3 is actually 64. So this is plus the cube root of 64, which just so happens to be a perfect cube. Okay, so then 48, the cube root of 64 is 4. So 48 plus 4, the answer to this question is 52. On your own 7 and 8, some of these are kind of tricky, so be careful. You are plugging in 64. So this is going to be the cube root of 8 times 64 plus 64 again. Why do I keep doing that? Go back. Oh my goodness, there's a list of perfect cubes that I was looking at earlier. All right, so sorry. And -3, you're going to plug into here as well. So this would be 2 times -3 minus the cube root of 9 times -3 underneath. So that should help you on your own number 7 and number 8. Lastly, we have some real-life application problems that have to do with surface area and the volume. Remember from your time in 6th and 7th grade math that the volume of a cubed is equal to the side times the side times the side, which is side cubed. And the surface area, which I abbreviated as SA, is equal to 6 times the side squared. Okay, so that'll help us with this real-life application problem. So we need to find the surface area of this baseball display case first. So the surface area is 6 times S squared. The problem is that doesn't really help me because I don't know what S is. I need to find S first. And actually, to find S first, we're going to use information that they gave us to solve for S before I can find the surface area. So let's use this equation first over here. Volume is equal to side cubed. If the volume is 125, and that's equal to side cubed, in order to solve this, remember we talked about inverse operations. In order to undo something cubed, all you have to do is take the cube root. So remember when I said when you take the cube root of something and you cube it, you're left with what's underneath, which is why we're left with s. And if you take the cube root of one side, remember what you do to one side of the equation, you have to do to the other side of the equation. So I have to take the cube root of both sides. And the cube root of 125 is 5. So now that I found s is 5, I can use my surface area equation, which is 6 times side squared, and I can plug in 5 for my side. So my surface area here is equal to 6 times 5 squared. You learned in the last section that 5 squared is 25, and 25 times 6 is 150. And if we're talking units, units in surface area, volume's inches cubed, but surface area is inches squared. Okay, so that one was kind of tricky. The reason we found volume first was because we needed the s. The last on your own used the same strategy we used before. So the volume they gave you is 512. Use the volume equals s cubed to find s first. And then find, there it goes again, good grief. Then find the surface area, which is surface area equals 6 times side squared. So follow the same process we followed in the example above. And that is it for section 7.2, finding cube roots.